Proving by induction, this is a sums example for Leaving Cert higher level. We're being asked to prove that the sum of these natural numbers, 1 plus 2 plus 3, add up to n over 2 times n plus 1. Here we have a template for solving this type of question. So proof by induction involves 4 steps always. First, we're going to show that it is true for the smallest value of n. Usually this is n is equal to 1, as in this case. So we're going to show that p of 1, when I substitute 1n for n, that it would be true. So, and then the left-hand side of the equation would be just the number 1, and the right-hand side of the equation would be I'm substituting 1 in for n in the expression. When I do that, I see I'm getting a half times 1 plus 1, which is 2. Of course, that's equal to 1. So it's true. 1 does equal 1, so it works for 1. Step 2 is I write that I assume it to be true for n is equal to k. That's saying that 1 plus 2 plus 3, right up as far as k, would be equal to when I replace n for k in the expression. So I'm going to assume that that is true. We're halfway there. This is the big step here, step 3. We're going to prove that it is true for n is equal to k plus 1. Now, for n is equal to k plus 1, what I would be doing is I'm adding k plus 1 onto the right-hand side of my assumption there. So it's k plus 1 more than for n is equal to k. And that would be equal to the same as if I substitute k plus 1 into the expression. I'm showing you here, I'm putting k plus 1 in instead of n in the original expression. So if I show that this is true, I've proven my point. So the few things I could do, I could expand both sides if I want. I'm going to factorize the left-hand side to show these to be true. So on the left-hand side, I have a fraction in the first part, so I'm going to multiply the second part here by 2 over 2, because I'm going to add fractions here. I'm going to tidy up the right-hand side here because 1 plus 1 is 2. When I factorize this, I note that each of the 2 terms on the left-hand side are been divided by 2 and have a k plus 1 in them. So I'm going to take that out. So it's k plus 1 over 2 times k plus 2 is what's left. So I factorize that, and I will notice now it does look the same as the right-hand side. I'll call it the RHS for short here. So I have proven QED, I've proven what I've been asked to prove. So it is true for k plus 1. So the final step then is to state my inductive proof, state the conclusion. So I'm stating it is true for n is equal to k plus 1, provided that it is true for n is equal to k. It is true for n equals 1, that's what we've proved. Therefore, it is true for all n where n is an element of n natural numbers.